The water above X is receiving heat energy from this heater, and when the water particles or the water receives energy, initially they expand. And expansion means their volume is increasing, so it means their density decreases. And these low density particles, they rise to the top part or the further upper portion of the heater, and the molecules which are not heated, their density is higher, so they move down to replace these particles. Question number 3 says figure 3.1 shows a hot water tank contains two electric heaters X and Y. This is the hot water heater. We have cold water coming in from this side. There is a heater Y, there is another heater X, and this is the insulation of the electric water heater, and the hot water goes out from this outlet. Heater X is used during the daytime, but heater Y is only used at night when electricity is cheaper. So normally heater X is being used in the daytime, and heater Y only used when uh, it is needed to be used at night when the electricity is cheaper. The tank is full of cold water and X is switched on. The temperature of all the water above X increases very quickly, but the temperature of the water below X increases much more slowly. Explain the process that causes the water above X to increase in temperature. The water above X is receiving heat energy from this heater, and when the water particles or the water receives energy, initially they expand. And expansion means their volume is increasing, so it means their density decreases. And these low density particles, they rise to the top part or the further upper portion of the heater, and the molecules which are not heated, their density is higher, so they move down to replace these particles. This is the phenomena which happens here, and it is called the convection. So the first thing which happens is that expansion of water happens, it is heated. This is the first point. Then density of this water decreases, so it rises, and cold water falls to the region near the heater, and a convection current is established. That is why the water which is above X is heated much more quickly than the water below the heater X. Heater Y remains switched off. Explain why the temperature of the water below heater X increases much more slowly than the temperature of the water above heater X. Now the water which is below this heater, their molecules would receive energy, and they could only pass this energy to their neighboring particles by a process called conduction. When they hit those molecules or particles or their neighboring particles, they transfer this energy to their neighboring particles. And they, when collide with their neighboring particles, they transfer this energy to them. And this process is called conduction, where particles or the molecules do not change their position, They pass on their energy to the neighboring particles by colliding with them. And the process of conduction is very inefficient in liquids since there are relatively larger gaps in the liquids than solids, and the particles, they are not efficiently connected with the other particles. So the process of conduction is inefficient. The energy transfer or the heat transfer takes place very inefficiently or slowly. So this is what we have to explain it here, and there are 2 marks for this answer. So the first thing, water below X is heated by conduction. There is no convection current establishing here. And conduction is inefficient because water is a poor conductor. So water being a poor conductor does not conduct heat energy very efficiently. The next part says the hot water tank is covered in a thick layer of insulating material. The material is a plastic that contains a large number of small pockets of trapped air. Explain why this material is a good insulator. Insulation is being made in such a way that there are pockets which contains air in the insulating layer, and the presence of air makes it a better insulator because air is a slow or a very poor thermal conductor. So heat is relatively trapped better inside the heater. So since the material is a plastic and it also contains small pockets of trapped air, so these two in combined are poor conductors. There are no free electrons in plastic, that is why it is a poor conductor. And trapping air also prevents convection in air. Since the air is trapped and it cannot change its position, so the heat energy to the external air could not be transferred easily. So these are the reasons why this arrangement makes up plastic combining with small pockets of trapped air makes a very good insulator for this type of application.